be going live. Live any second now. Okay, hopefully that's working. So thank you for being patient with me. I understand some of you, well, the few of you that are watching, are have been waiting for some time. So I'm just making sure everything's set up properly. I think we're good to go. All right, cool. So over here I've got a exam. Is that picture loading? Or is that frozen? My screen's not working so well. Oh, it's okay. It's slightly delayed. All right, all good. So I'm going to start going through an exam. So this exam's from 2016. I'll be working on that today, at least to get through it. And hopefully you guys find this rewarding and beneficial. And if you do, please let me know. And I will try my best to do another one again. Yeah. Of course, if you don't find it beneficial, then it's fine to let me know that too. Okay. So, the screen here. Load up my CAS. Got my CAS ready to go, as you should do. Alright, we're going to just start with this data and analysis question. What it says is it says that the data shows below recent results of a survey conducted on the price of concert tickets. So before I even start, I'm just gonna underline what it's about. So it's about the price of concert tickets, right? Locally, and the price of the same concert at an international venue. Okay, so it's the same concert at an international venue, right? And we've got a stem plot from there. What I'm going to do is, first of all, first question says, what's the most expensive ticket price at an international venue? So that's obviously saying that on this hand side, or the right hand side, plot, which ticket was the most expensive. That would be the last one here, which is, and if you look at the key, you can see that 6 and 0 make 60, so 10 and 0 would make 100, 10 and 9 would make 109. The most expensive ticket is $109. It says calculate the median ticket price of the concert at the international venue. So median, if you think back to what median is, it's the middle value. So I'm looking for median ticket price at the international. It's important to make sure that you're reading through these questions properly, because it's very easy to a lot of people that make mistakes tend to make mistakes because they can't, I guess they don't read the question properly. So we're looking for the median ticket price. That means the middle ticket price for international concerts. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If I have 20 values overall, that means that the middle value, if you remember your formula for this, is n plus 1 divided by 2, will give us our middle value. Somebody else has arrived. Before it was just me and Thomas, and now somebody else is here, so good job for being here. I appreciate it. So I lost track of how many numbers I had now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so 21 divided by 2 tells me that it's the 10.5th number. So what that means is that we're looking in between the numbers 10 and 11. Okay, so if I were to go to here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to look in this spot right there. Okay, so what that spot there means is it's halfway between these values. So if I wanted to find that median value, it's somewhere between 86 and 89, right? It's in between those values. So what I'm going to do is I'm going to add them up together. So it's 86 plus 89 is 175 divided by 2, it should give me 87.5. But of course, it's not just 87.5 anything, it's $87.5. Make sure you put that in there. Okay? So I guess that's how I would approach that question so far. Let's skip on to the next bit. I might just keep my data over here somewhere so I can refer back to it. Calculate the 5-figure summary for both sets of data. Okay. So what I might do now is, because I'm asked to do a whole bunch of questions in related to this data set here, I'm going to type them into my CAS. So if you jump over to the CAS document, to list and spreadsheets, we have local. It might be a bit hard for you to see the CAS at this stage, but I'll make it a little bit bigger. I'll make this a tiny bit bigger just for now, just so you can, hopefully that helps. There's local and international, so we have local and inter, right? I'm just going to enter these values in. Starting with local, we have 64, and we have 64, 69. Waiting for those jokes to start coming in about that. 72, 74. Maybe I won't read all these numbers aloud to you. So just give it a second and I'll get all these typed up. I'm going to try and keep an eye on the chat as well, so then you can ask me questions and I'll try my best to answer them. I do have somewhat of a delayed feed though, so don't expect me to be on the ball immediately. 7, 98. That's a good question, actually, the one about the books. So Miss Bishop will be the one checking them during the exam, so I recommend her checking them off for you. But no, technically you don't have to have them seen by her. But then if you get it watched by somebody else and then she takes the book off you because they missed something, there's nobody you can really blame other than yourself. Hope that answers your question. Yeah, we have short answer tomorrow and multiple choice next week. No problem. Oops, stop that one up. All right, I think that's all my data. I don't necessarily need it for the next bit, but I will have to do. I saw on the next page that I have to do Fox plots, so I figured that I might as well enter it in now rather than do it. Okay, so what we're asked to do now is we're asked to do a 5-figure summary, so we can actually do that on the CAS. We've got stats, stat calculations. Can I do it this way? I think I'd have to do them individually with one variable stats. So I'll do local first. can spit out my answers in this column. Okay, so this is our 5-figure summary here. We have, sorry, there's just a teacher looking at me through the window. We have min, Q1, median, Q3, and max. So let's write those out. Now that's worth 2 marks, which is probably worth pointing out. So I would probably write my my CAS steps on top. So I'd say 1, enter data into data and stats. That's what data and stats. List and spreadsheets. So list and spreadsheets. And I went, you're a better YouTuber than, oh, that's funny. I've built time. I've got some serious face rubbing to do. And list and spreadsheets. And then we're going to, what else do I say? I say that we did 1 variable stats for each. All right, that's probably enough to give me the working out thing. No, hang on, please. Yeah, that's true. Yeah. I'll make sure he watches it, but don't worry, it's not like he'll figure out who you are. So we have, I'll say local and international, and we'll have min, Q1, Q2, or median, Q3, and max. All right, camera angles. Oh, can I move the paper down? Sorry. Hopefully is that easier to see now? I'm trying to view it in my my feed, but yeah, that's better. Okay. So then we have 60, 72.5, 81.5, 92, and 103. Right, that's that one. Now I'll do the other one quickly. So again, menu, stats, stat calculations, 1 variable stats. This time we're doing international. So min 65, 77 for Q1, 90 for Q2, 99.5, and 109. All right. With questions like that, because it's worth 2 marks, I would definitely put in my working out, even if it's asking for 2 sets of data, just in case. Yeah. All right. Next bit. I'm going to move the paper up. Actually, I'm going to make this smaller. So I don't have to muck around with that as much. All right. Cool. All right. So let me get that back into position. So now we need to comment on the 2 data sets and compare shape, center, and spread. All right. So we're going to make sure that we comment on both of those, shape, center, and spread. And you need to comment on both data sets at the same time. So I would start off by saying that if you look at let's have a look at the data. Actually, you know what? I think that maybe making this a box plot might make it easier to have a look at. Let's go to insert. Let's have a look at local first. No, not that. All right. So the local data, that's what it looks like. I would say that's pretty much symmetrical, maybe slightly positively skewed. So I'll say is local. Maybe I'll write in for you. The local data is Mostly symmetrical. Mostly symmetrical. I'm trying not to move the sheet because I'm probably can't see it. Mostly symmetrical. Maybe in another tab, I will add another. We're gonna have to look at the international one here. We're gonna have to do them as parallel in a second anyway, which is annoying because it's another step. But, put type. Let's put. Okay. So I guess looking at that one, you could say that because most of the data, and you can't see what I'm circling, because most of the data is clumped around the right-hand side, it means that, well, not most of the data, 50% of the data is, but that's got a smaller range than this one, right? Which means it's being skewed off to the negative end. That's probably. Did I write 009, not 109 in my data? Or did I fix it? I'll have a look at that in a second. I was going to do a multiple choice live stream on Wednesday. So probably just short answer for today. Yeah. Okay. So since it's all since this side of the data is skewed to the left, it means that it's negatively skewed data. So I'm going to say international is negatively skewed. Right. Now we go to center. Center, you say the median is 81, and then that one, the median is 90, which I actually have at the top here. What I can say is that international is generally more expensive. With a median of 90 compared to local with 81.5, right? So the median indicates that, like, that's almost on average, it's more expensive, but we don't say the word average. I see what you're talking about. This is where I wrote 009. I'll fix that. And then finally, the spread. There's a couple of different things you can pick for spread. I'm just going to say interquartile range. So if I look at that, the interquartile range for local is 19.5, and for international, it's 22.5. So I'll say international. I just realised how bad my spelling is. National concerts were more varied in price. With an IQR of, so it was, what did I say? It was 22.5 compared to local with, and that was 19.5. All right. I sort of worked out in my head. So when you're talking about the CAS steps, I only did that because it was worth 2 marks, and then to me it felt kind of like a 1 mark question. So I just say cover yourself whenever you need to. If you're doing a calculation, if it doesn't feel like a 2 mark question, just do it then. But you're not going to lose marks for writing it. All right. Find the range of ticket prices at the local venue in the middle 50% of the data. Okay, well that's easy because I just figured that out. So that's a complicated way of asking for the IQR. So the middle 50, looking for the range of the middle 50, right? That's looking at, if we have a box plot, I'll draw this so you can see it. If we have a box plot, the box is 50, the middle 50, and then there's 25 either side, right? So it's asking for the middle 50%. It's just asking for the IQR. So the IQR for the local venue was $19.50. And that's just the one mark question, so I don't even need to write my working out, I guess. Use a calculation that shows there are no local, there are no outliers. All right, now this question is a good question to be looking at. Let me just scoot this up a little bit. Purely because I guess what it's asking is to find if there are outliers or not. And it'd be very easy for me to look at this, right, and say there are no outliers, and I can tell because I'm looking at a box plot. The main problem with that is that if you do that, you're not showing a calculation. See how that says use a calculation, and then show mathematically. So it means we're going to have to use that upper and lower fence stuff. We'll do upper first, which is 1.5 times IQR added on to the Q3. Right? It's probably written that round the wrong way, but that's okay. So what that is 1.5 times 19.5 added on to Q3, which is 92. Right? So let me jump back into calculator and see if I can figure out what that's going to be. So 19.5 times 1.5. Okay, so 29.25 plus 92. It's 121.25. Right? And there's nothing over that. If you look at my maths, it's 103. So it's easy. So there's none there. If I look at lower, it's I should write it the right way this time. So it's Q1 minus 1.5 times the IQR. All right. So in this case, it's Q1, which is 72.5 minus, what was it, 29.25. That's 43.25. Right? So they're the two fences, and I'll say that there's 43.25 is less than the data, which is less than 121.25. Therefore, no outliers. Right? Yeah. Can you please make the decimal points really big? Yeah. I'll try and remember to do that. Make it a bit easier for you to read. Right. Hopefully that helps a little bit. And then the last one says sketch parallel box plots, which is great because when I originally set this up, I just set it up for regular box plots. So what I'm going to do is to do parallel box plots, you need everything in one data set, which is good because I'm on my computer. It's a bit easier for me. I think I can just copy paste. Copy. Paste. That work? Nope. I just deleted everything. Okay. Well. I guess I'll just write that back in by hand. Yeah, this here. Just taking a second, so yeah, take this opportunity to go make yourself a sandwich and get a drink, settle in. Right. Right. So we're going to get rid of this. So what we're going to do now, again, I might pop this up and make it a little bit bigger, is I need to identify the type, I guess. So this is almost like, this becomes like data now, and this becomes whether it's local or int. I'm going to say L or I, lorry. Right? So that stands for local or international. And I'm just going to quickly put all these in as L's and all these in as I's. Alright, so I got that. Now when I go back into my, let's just do another one for the sake of being tidy. Now I put my data at the bottom. I put my type on this lorry on the side. And this time when I make it a box plot, I get parallel. Alright? So that's going to be how I'm going to sketch them. So I guess I'm just going to, and hopefully when you do this in your exam, you get to use a ruler or something. Mine's going to be quite poor, I guess. So I'm just going to put in some values. They're hard to read. Probably is a little bit hard to read, eh? Let me go over it in darker pen. So it's 60, 70, 80, 90, 100, 110, 120. Don't need to go any higher than that anyway. Right? So my first one goes from, so local, so this is local, add a value here. My Q1 is 72.5, so it's probably about there. My median is 81.5, so it's about there. My Q3 is 92, which is about here. And the end of it is 103, it's probably about there. Right. I'll just join up these little ones, join up the big ones. Right. That's that one. I'll do the other one in black just to make it stand out a bit more. So international has it at 65, 77, 90, 99.5, and then 109. Right. Cool. So yeah, I guess the marks allocated for that are probably for correct labeling, correct box plots, roughly a correct scale. That'd be where your marks are being allocated. Yeah. All right, let's move on. Hopefully that question is done on bits, isn't it? Okay. That question is done, so that's good. So now we're looking at the number of pages in students' assignments. All right. Let me try and get that in shot. So, quite in. Just make sure that's right. Yeah, it looks at least somewhat easy to see. I think I want a bit of an angle with this, so don't want anybody negative OCD. All right. So this first one's a histogram. It's looking at how many pages are in a student's assignment. So it asks first how many assignments were there, right? Yeah, I think it's 2 marks for box plots and 1 mark for labelling. I would assume. I haven't checked the unit guide, but I would assume. So the number of assignments, you're just going to add up each individual column, and then that's your total amount. So we've got 1, 2, so we've got 2, and 5 is 7, and 7 is 14, and 5 is 19, and 2 is 21, 24, 25, 25 assignments. Right? And that's simply just a 1 mark question, so, too easy. The mode here is 5. Explain in the context of the data what this means. So in the context of this data, it means that the majority of students had, well, I guess what you want to think about is if you're talking about mode, it means most common or most frequent, right? That means the most, or for the most part, so most students did 5 pages, right? That's what that means. What is the median number of pages per assignment? Okay. So again, median is middle value. So I'm going to be going into, so I had 25. 25 plus 1 divided by 2 gives me 13. So the 13th value will be my, my median. So I guess you're just going to find where that value is. So 2, 7, 14. So the median is 5 as well. Right? Because I guess if you were to put this in order, it's a good idea to remember to I mean, you could just write 25. I was just being, that's 1 mark. If you write 25 and somebody doesn't give you the marks, they're just jerks, which I'm not. So 25 would be fine. I'm just trying to be thorough. So the median number of pages per assignment is 5. So basically, that means that, if you were to put all the assignments out in order, the middle one will be 5. Find the mean number of pages per assignment creates 2 decimal places. Okay, so now I'm calculating mean. I'm just going to do this. I'll probably do this on the CAS, just a little bit easier. So all I'm doing is plotting these values together. So there's 2 3s plus there's 5 4s plus 7 5s plus 5 6s plus 2 7s. Remember I'm doing plus 3 8s plus 1 9. All right. So that means overall there's a total of 138 pages. If I want to find the average, I'm going to divide 138 by the number of assignments received, which was 25. Right? So I'll divide that divided by 25. That's the control enter. 5.52. How many decimal places? 2 decimal places. So it works out well. 5.52. All right. So that's my name. What percentage of assignments had at least 4 pages? Um, this is a good question as well, because you've got to be careful with this language. At least. You got to think about what does at least mean, and in the context of maths, at least means this many or more, right? Because sometimes it'll say more than this number of pages, or less than this, or had at um, at most this, things like that. So you've got to be careful with that language because it'll get you. Okay, so at least 4 pages, right? So pretty much all of them had at least 4 pages. There was only 2 students that had 3. So I can tell from that, that means that there's 25 students, 23 of them had um, more than, also 4 or more. So that means that the total percentage, well, normally I just do this in the CAS, but because that's just, you just times it by 4, that would be 92%. With the percent sign, nice and big. Alright, so as another student joins the class and submits an assignment with 7 pages. Calculate the mean number of pages now and write your answer to 2 decimal places. Alright, all that means is that another student joins, so there's 26 students now, and they add an assignment with 7 pages. I mean, yeah, there you go. It's 145 divided by 26, right? So luckily we have this on here because it's like, you just go back and change things, make it nice and quick. And that becomes 5.58. 5.58. Yeah. Make sure you round that up because it's 576, so it's going to round up to 58. Yeah, that's that one. Too easy. All right. Table below shows the marks 12 students got in 2 tests out of 10. Which is the response variable? Okay, that's an interesting question because you're looking for the response, and the response variable is y. So it's the y variable. The x is always the explanatory. So if I'm looking for the y value, that means which one is going to change based off the other. And it says here that they're using the above information is used to predict the math mark from the reading mark, meaning that reading may explain maths. So I guess that's a tough one to figure out. Right? So the maths is the explanatory, reading is the response. Did I get that right? Oh no, sorry, it's the other way around. It's math. Yeah, sorry. I just explained it and then broke down the wrong word. Yeah, so they're using reading to explain the change in math. Right? So yeah, that's always a tough one. So it's basically what's being predicted is the y. Sketch a scatter plot. All right. I'll make my CAS a little bit bigger. And then we'll do a scatter plot. Let's go with some spreadsheets. So we have reading and we have math. And just give me a second to enter this data. You can send a text or share the live stream and talk about how wonderful it is. Whatever you want to do. Right. So that's my data entered. Obviously now I need to do a scatter plot. So I'm going to doc, insert data and stats. And on here I'm going to have, so if you, my response is mapped, my X is reading. That's my scatter plot there. So I'm just going to draw a quick sketch of this. We got 2, 4, 6, 8, and 10. This goes all the way up to 20. I have to add on a bit here. Alright. Alright, so that's that. Now I'm just going to go through and just sort of plot these roughly where they should be. And you can do this either off the board or from your data up here, whichever one you want to do. Probably best to do it from the data actually. And this is reading, this is maths. If my reading is 10, my maths should be 7. My reading is 6, my maths is also 7. My reading is 6 and 10. My reading is 8, so my maths is 7. My reading is 19, my maths is 10. Right. 4 and 4, which is nice and simple. 8 and 6. 2 and 1, I've already done. 5 and 5. 1 and 3, I've already done. 7 and 9. 4 and 3. Alright, so that's my scatter plot. Far out, that was just like full on. We can just copy the tables on the CAS to the nearest representation, but not exact, but close enough. Yeah, yeah, you can. Just try and do it as close as you can. Like if you think I'm going to sit there with a ruler and make sure each one of those points is exact, and you're dreaming. So yeah, as long as it's close enough that I can see. All I'm going to do is I'm going to bring up this exact picture that's on my screen here. Look at what you've got and be like, does that sort of look the same? You know, that's about it. In terms of breaking down the marks for this question, there'll be marks for getting the scatter plot, and there'll be marks for doing each axis correctly. And then I'm not too sure what the other mark would be for. Hard to say. I wouldn't have given 3 marks for that. I wouldn't have given 2. Maybe I'd just gave 3 because it's going to take a while. So it might be 2 for the scatter plot. No, unless this is an outlier. Maybe you're supposed to sketch it with an X or something. All right. Describe the association between the two tests in terms of direction and strength. All right. I'm assuming it means off what we've done. Using the ruler to draw the line. Yeah, you're supposed to use the ruler to draw the lines. That could be what the marks are worth. So we can get this exact value, and then we don't need to muck around with this. Stat calculations. 2 variable stats. We have reading and maths. And that can tell us our exact correlation coefficient. Does it? I must have done. Never mind, that's just me making a mistake. Linear regression is what I want to look at. Reading maths. You can go back and see. Yes. All right. There you go. So my R value here is 0.72, which I believe means that it's technically a moderate association. There is actually. I'll bring up my notes for a second. What am I doing? This way. There's actually a great table that I recommend that you have written down in your book, which is this one here. Right? Always have this written in because it's very easy to forget these values. So in this case, the correlation coefficient was 0.72, which means that it fits into this moderate positive linear. Right? So it's moderate positive linear. Right? Easy as that. Yeah, good. It's definitely worth having. Find the Pearson's correlation coefficient and give us the two decimal places. Well, we've already done that, so it's good. So it's 0.72. All right. And obviously, because that's 0.2, it rounds down. I hate Pearson things, but yeah, no, it's super useful. It's so good. Yeah, that's it for that. Nice and easy. Okay, so it says explain the variations in 1 mark. In maths, must be explained by variation in reading. Okay. So basically, when you get a question like this, it's about showing understanding of this is basically the sentence structure for coefficient of determination. Right? Which is basically just R squared. So R squared is 0.52, which means that 52% of the variation in mass can be explained by variation in reading. Okay, write down the least squares regression line with coefficients corrected to this. Okay, this is another easy one, nice and simple. It's assumed that you're going to use the CAS for this, so I don't really need to write down the steps. The 2 marks are definitely going to be allocated to the values and the correct use of variables. Right. So it's y equals nx plus c, and instead of that, it's mass equals my n is 0.45, two decimal places, yeah? 0.45 multiplied by reading plus our C value, which is 3.01. I'm just getting that off the CAS screen, right? So yeah, 1 mark for values and correct rounding, 1 mark for variable names. What does the slope of the regression line? What does the slope of the regression line interpret? That's a very badly worded question. I think they basically mean interpret the slope of the regression line. And that would mean that for each 1 mark gained in reading, mass will increase by 0.45. Right? That's basically it. Predict the maths mark to one decimal place using the above model if the reading mark is 7.5. This is just a substitution question, nice and easy. So math equals 0.45 times 7.5 plus 3.01. Right, it's not so bad. We jump into the regular calculator, whatever that is. I'm a bit lazy, don't want to do that. 0.45 times 7.5 plus 3.01. So it would equal, so mass would equal 385. So it's rounding to one decimal place. So it's important to read that. So 6.4. Right. Popular. Oh, somebody was watching and they got over it and left. I've lost someone. That's okay. Some people are still on their way back from their exams, so it doesn't bother me too much. All right, got some more data here. This is the last bit that I have to do for data and stats, and then I get to do matrices, which is a bit more fun. So that's good. All right, these are measurements made. Oh. All right, measurements made on 12 men. The scatter plot shows that there's a strong linear relationship between weight and waist measurement. Find the least squares regression line that would enable weight to be predicted from waist measurement connected to decimal places. Okay. So all this is asking me is asking me to find the least squares regression line. Again, those marks can be allocated for variable name and values. Then I'm doing a prediction, and then I'm doing a interpolation, extrapolation thing. So let's jump into the scratch pad. What do you call it? Excel thingy. And it's interesting because in this data, there's another column called age, which is just pointless, I believe. All right. Give me a second while I type all this in. Yeah, age is definitely there to just throw you off. It's what they call a red herring, which means it's just a distraction. Alright, so my data's entered. Yeah, maybe. Yeah, it doesn't seem to be of any value to the rest of the question. But alright, so I'm doing stat calculations, linear regression. Now, which one explains the other? So, weight against waist. So, it would enable weight to be predicted from waist. So, waist is X. Waist is X and explains weight. Alright? Predicted from waist. So, waist explains weight. Yeah, good. Alright. So, these are my values here. So, again, it's y equals mx plus c or plus b on the case for some reason. And we're going to say that weight, which is the y, weight, yeah. So weight equals 2 decimal places, 1.11 times waist plus minus. It's a minus, so plus minus 19.97. Okay, all right. So now we've got to predict the weight of a man who has a waist size of 83. So let's do that. Every time I forget, I have the wrong thing open. All right. So 1.11 times waist, which is 83. That value minus 19.97. Right? So somebody with a waist of 83 centimeters is predicted to have a weight of 72.16. And again, that's a 1 mark question. I might put kilograms just in case. Predict the weight of a man with a waist size of 140. Explain why this prediction is not reliable. So that's obviously where the 2 marks are coming from. Let's just do this again. And the weight of a man whose waist size is 140. So he would weigh 175.43 kilograms. Right? So that's the first bit. And then you would say it is unreliable because you are extrapolating the data. Right? So it's extrapolating is when you go through, there's no waist size bigger than 126. So that 140 is outside of the data, which means it's extrapolating. All right, that's that done. Oh, yeah. I actually hate data stats, that's what I do. Makes these much nicer. Okay, so we're going to find the matrix product AB. This is just a 1 mark question, so I'm just going to do it on the case. The further into the test, generally speaking, yeah. I mean, we try and lay it out because we don't want to scare you away. So we try and put a couple of easy ones at the start. But that doesn't necessarily mean that the last question is always the hardest. It just means that we sort of let you ease into it a little bit. Right, it's an easy question. It's only 1 mark, so I don't need to show any working. How great's that? This is already scaring you, scaring you away. Well, I don't know what to say. You have an exam tomorrow. Don't be scared. Explain why you were able to find matrix product AB. So this question is just testing. It's not supposed to be scaring you away. But keep in mind as well, I'm doing this without a resource. You guys have a book that you can bring in. Your mum's scared. Oh, yeah. Look, I tend to not put explanations into the lesson PowerPoints unless they've been taken by somebody else, because like I know how to do all this, so I don't really need comments. They're usually pretty well broken down those on the actual slides. So just have a look. We can watch some of the other videos, maybe some help with that. Yes, that's true. That's true. I do teach this subject. So what this question is asking now, so let me move it into shot. I think this CAS is still in the way. We don't really need that as much now. So what this question is asking is trying to check to see if you understand the multiplication process. That's it. So all you need to say is because the row, the columns in matrix A were equal in number to rows in B. Right? So it's just a check to make sure that you understand the multiplication process. And that's just, you know how when we multiply things, you do that check or you write the thing underneath it and if they're in, that whole thing. So I'm not good at explaining, which is probably says something about my job. So yeah, if the columns in the first one are equal to the rows in the second, it means that it can be done. So that's why these is possible. Matrix A is an order of 3 by 3. The matrix product has an order of 3 by 2. What will be the order of matrix B? All right, this is a good question. So this is another one where it's sort of like, so the first one is a 3 by 3, and the second one is a by B. I'll say that at the moment. They've checked and they've said the multiplication works. Is more of the short answer going to be on matrices? So it's going to be, I think it's slightly leaning towards data because we spent more time on it. Yeah. So we're checking, so you'd have to say that these two numbers are the same, which means that A would have to equal 3. And if the order was a 3 by 2, that means that B would have to be 2. So matrix B has to be a 3 by 2. That's a bit of a complicated question, I guess, with a bit of lateral thinking, which is always a little bit scary, but it's not so bad. All right, next question. The matrix below is cost for travelling between Princeburg, Corana, and Risdale. All prices are in dollars. There's zero entry means there's no direct route possible. Between which two cities are there no direct route? So between Corana and Risdale. All right? And the way that you know that is because you know that the zeros down the middle are there because it means that you're travelling to that exact location, so there's no point. So R to Q and Q to R are the ones that have no direct route between the two. If Stan wanted to travel between Corona and Risdale, so that actually gives away the answer to the previous question. What would be the cost for his trip? So you would have to go from Corana to Princeburg, and then from Princeburg to Risdale. So it would be 82 plus from Corana to Princeburg, from Princeburg to Risdale, so plus 46, which is $128. Okay? Yeah. Update matrix K and rename it P so it shows the actual cost of travelling by indirect routes. So I'm assuming that wants to have these written in there. That's a dumb question as well, like realistically. Because then if you get that previous question wrong, they have to give you consequential. Matrix T shows the amount of trips taken by executives of the Tangiers Trading Company during the month of April. Calculate the matrix product PT. Okay. So again, this is a 1 mark question, so I'm just going to whack this into the tags. So we're calculating P times T, which is also 3 by 3. Yeah. On the exam, if you get it wrong, we do consequential marking, same as the SAT. So if your answer is wrong, the next question is marked according to your answer. All right? So don't stress about those questions too much. a bit of a useless calculation, to be honest. Yeah, yeah. Don't stress about those ones because let's say for answer B I got it wrong and I got 50, and then I wrote 50 in here. I'd lose the mark for B, but I'd get it for part C because I did the right skill. So did products PP or TP calculate the total cost of travelling between locations during April? Why and why not? Well, that's number of trips. Okay, so I'll go back to this one because this question is a tough question too. So what it's asking is, does the calculation of T times P or P times T find the cost of travelling? Yeah, so, and it says to explain why and how you know that. So what I would say is that uh, that's a tough question because it's like it doesn't actually give you. It's a bad question. It doesn't give you any information. Where's that coming down together? I would say neither of them really. Dex is on the end. Right, talk about animals later. Yeah, I'll be around tomorrow before the exam. I'll be getting to bed about 8, I think. I got to pick up somebody at 8 o'clock, so maybe like 20 past, hopefully. So yeah, come see me. We need help. Yeah, this is an awful question, guys. Total cost of travel. There's not enough information here to tell you because you don't know how that's laid out. So there's no point in me answering that question. My answer to that, it's probably wrong, by the way, would be neither. Um, I would say both matrices are 3 by 3, so they don't show total cost. Right? So actually, I don't know if that question's even right, to be honest, but it's just really badly laid out. To me, if that says do the right, okay, I misread the question. So do the products of TP or PT calculate total cost of travel between these locations? Why not? So they don't. Because both of them will end up being a 3 by 3. Yeah, you can have examples from the textbook or past exams, just not coursework. All right, let's keep this going. How far in are we? We're an hour and 10 minutes in, so you've done well to stay on this long. So find the inverse. Again, that's a 1 mark question. So I'm just going to do it on here. So you can have examples, you can't have coursework. So if you have an example from the book, it's okay, but if you had questions that you've worked through from the textbook, then that's not okay. So to find the inverse, it just raises to the power of -1, nice and easy. And this becomes -7, 5, 17. 17 and negative 12. All right, phone's going off. Right, great. Yeah, examples are, so if you went to Miss Bishop, maybe she was not too sure. But literally, you can have examples, but you can't have coursework. That's it. So you can't have like pages and pages of questions from your book, but you can have an example. Um, okay. So the next one says explain why this question here has no inverse. It has no inverse because there needs to be a square matrix to have an inverse. Inverse. Explain what it means if a matrix does not have an inverse. I guess you cannot use it to solve for an unknown. So if it was this matrix, I don't know if this is a good example or not. I mean, I'd be happy with this. Right? So if I came to school tomorrow, yeah, Miss Bishop's going to be there early tomorrow anyway. Yeah. So I'll be in F3 with her. Yeah, I'll be here. So just come in whenever you get here. I think I got period 1 and 3 on. I have to double check, but I'll be around. Right, that's that. Um, so we have simultaneous to find the day. Oh, I still need this apparently. The answer from part A. Okay, so how can they tell what all the examples are? So when if you've got a page that has just question numbers down the side, and you've clearly just been smashing through all these things, just label it, just write example, and just have a question, a bit of writing, things like that. You can't just write out a whole bunch of practice questions. That's basically it. Yeah, I hope that helps. All right, so my answer from part 1 to find, so I'm assuming that there's 2 marks in this question, which you probably can't see right now. There's 2 marks in this question allocated to correctly rearranging the equation and for solving. So first one, I'm going to rearrange. I'm going to say x, y equals, now I'm going to write out my inverse from before, which was negative 7, 5, 17, and negative 12, multiplied by this. I'm going to have x and y equals, I'm just going to do this calculation on, yeah. Yeah, write the PowerPoint and topic, just label them as examples as well. If she asks you, like you're allowed to have examples, so don't worry. If she asks you, just tell her that they're examples. Multiplied by, yeah, just do that. Couldn't hurt. Right. So our values of x and y are 620 and 1150. And then this part of the question here, D, says find the daily cost of operating an agent overseas, which is what y is. So it would be 1150. Right? Make sure you read that there, because otherwise you're probably going to lose a mark for not interpreting it correctly. Right. Question 4. These are secret agents with lines of communication, etc., shown in matrix N below. How many pairs of agents just have one line of communication between them? With A and B, there's A and D, there's B and C. So I guess what I'm doing here is I've sort of split this in half because it's symmetrical, and I've just identified the ones there. Right? So 3 pairs of agents. Calculate n squared, nice and annoying. Is that a 4 by 4? I wish I hadn't drawn all over that. So all I'm doing is finding this squared. Jesus. Right. That's only one mark question, so I don't need to show any working. Nice and easy. It is necessary, sometimes it has to be sent to an agent via a third agent. This is known as two-step communication and transfer. And the two-step communications between agents A and C. Alright, I need this back. This is A, B, C, D. A, B, C, D. What this is asking is how many lines of communication are there between agents A and C? Alright, so between A to C, it's 4. If you want to check it the other way, A to C is also 4. So 4 lines. So there's 4. And in terms of the number of two-step lines of communication, what the entry in the third row and the second column of matrix n squared is. Third row, second column, 8. So there are 8 lines of two-step communication between agents. What was it? It was row. So it was row 3, column 2. So it's C and B. Agents C and B. Right? So that's out. Let's answer that question. So how does 0 squared do so it's not 0 squared. Remember, it's this times this. You're not squaring each individual value. So you're doing this row times this column. So that's how you get your 6 from. All right. And that's the last of it. That's all I have to offer. I appreciate you guys taking the time to watch it. It's like an hour and 20 minutes of your time you've given up to listen to me ramble. I hope that you appreciate the thing. I'm just going to chuck a card up quickly if I can. Just so you can give me a bit of feedback. Uh, I don't know how to put the card up on the screen. Hopefully, it's doing it now. I don't know. Hopefully, there's a card up that you can have a look at that'll let you vote. Yeah, gonna watch it anyway. Cool. That's probably what to expect tomorrow. Yeah, I would say that probably the buy variant might be slightly shorter. Oh, actually, no, it's not too bad. I reckon it's probably about right. Um, how you were talking to me through the TV, I could feel it. Anyway, I'm gonna leave you. Yeah, thanks for taking the time to watch it, and I'll try and upload this by the end of tonight. Hopefully you enjoyed it. If you did, I'll do another one. Well, I mean, regardless, I'm doing another one on Wednesday. I'll send out the time and everything again. Um, so yeah, that's it, I guess. Goodbye and good luck.